All right, welcome to Integrated Math 3 Notes 8-2, Solving Square Root Equations. So we're on page 107. So we're going to solve square root equations and identify extraneous solutions. Okay, so here are our steps. We're going to refer back to these 4 steps over and over again. To solve a square root equation, we're going to isolate the radical term. That means we should have the radical equals something. We're going to square both sides of the equation. So we'll square the radical, we'll square the other side. We're going to solve for unknowns, and then we will check for extraneous solution. So the word extraneous means not needed. In math, sometimes a solution seems to make the equation true, but when the value is checked, the value makes the denominator a 0 or the radicand a negative. So that's what an extraneous solution means. All right, I do have some additional paper taken out. Again, I'm going to encourage you at any time during the notes, if there is a step that you don't understand, pause and watch it back again. And if there's still a step that you don't understand, make yourself a note to ask me in class. Okay, so we're going to do example A. So this is page 107, example A. It says to solve the square root of x minus 3 plus 4 is equal to 9. All right, so to solve square root equations, we're going to first isolate the radical term. That means I need to get the square root by itself, subtract 4 from both sides. My 4's would cancel. I get square root x minus 3 equals 5. All right, and then it says next I would square both sides of the equation. So at this step, by the way, if you get something like the square root equals a negative value, you can stop because that's not true. A square root cannot equal a negative. So you can stop, there's no real solution. All right, so we're going to square both sides. Squares and square roots are inverses, so we get x minus 3 equals 25. And then it says solve for the unknowns. So I'm going to add 3 to both sides. And we get x equals 28. And the last step is to check for extraneous solutions. So we're going to substitute our value back into the radical and make sure that it keeps our equation true. So we're going to do a check. So we've got x equals 28, so x minus 3 plus 4, right, and then 9. So under our radical, we're going to get 25 plus 4 equals 9. Square root of 25 is 5. 5 plus 4 equals 9, and that's true. So it is a valid solution. We have one valid solution, and that's x equals 28. All right, and so you can see they did the same thing. They had x equals 28, they checked it back, and they did get, indeed, that it was a valid solution. All right, we're going to do example B. So example B, it says to solve the equation x equals x plus 1 to the 1/2 plus 5. Now, you may not think there is a radical, but remember that to rewrite something like a, the square root of a, this is the same thing as a to the 1/2 power. So here is my radical. I'm going to rewrite it as x equals the square root of x plus 1 and then plus 5. Okay, now we're going to begin solving. So it says the first step is to isolate the radical. So I'm going to isolate my radical by subtracting 5. And that's x minus 5 equals the square root of x plus 1. Again, you guys should be referring back to these steps. Isolate the radical term I have. Next, I'm going to square both sides of the equation. Now, when we square both sides, we have to square this entire side. That means I need to put parentheses and square the entire side. On this side, it's pretty straightforward. The square and the square root are inverses, so we get x plus 1 equals. Now, x minus 5 squared, x minus 5 to the second power, means x minus 5 times x minus 5. I'm going to use a generic rectangle. X minus 5, that's x squared, negative 5x, and 25. Combine like terms within the square, I have x squared. This is negative 10x plus 25. And then solve for my unknown. My unknown is x. So now I'm going to have to subtract from each side. I'm going to have to subtract x from each side. I'm going to have to subtract 1 from each side. This gives me x squared minus 11x plus 24 equals 0. Now you may wonder why this time I wanted to move everything to one side versus the previous time when I wanted to isolate x. So this is from Math 2. This is one of those topics that you have to know that when you have a quadratic, which you do, to solve a quadratic, you need to have it set equal to 0. So make yourself a note. To solve a quadratic, you must set it equal to 0. Now at this point, you can try factoring, or you can try using the quadratic formula. So let's check factoring. We're going to see if this solves by factoring. If not, we'll use the quadratic formula. So I want something that multiplies to positive 24, but adds to negative 11, which is negative 8 times negative 3. So this is factorable. I'm going to rewrite my middle term as minus 8x, minus 3x, and plus 24. Remember, I am factoring by grouping. All right, so then I'll split and take out the GCF of each side. So the GCF of this side is x. That gives me x minus 8. Bring down my sign. The GCF is 3. That gives me x minus 8. I will group my common factor together, which is x minus 8. And then to get this term, I need an x. To get this term, I need a minus 3. Now I'm going to apply the zero product property. So the zero product property says I take each factor and set it equal to 0. So I have x minus 8 equals 0 and x minus 3 equals 0. And then I'd add 8 to each side. That gives me x equals 8. And then I'd add 3 to each side. That gives me x equals 3. So I have two potential solutions. I'm going to go through this one more time. So the first step was I isolated the radical, which I did right here. Right? I moved the 5 over. The second step was to square both sides. So to square both sides, this squared, right? I have to be careful when I'm squaring a binomial. I have to multiply it out. I used a generic rectangle to do that. Right? Sorry, this squared, right? I need to use a generic rectangle. And then I did that. I got 10x squared minus 10x plus 25 equals x minus 1. Now, the next step says to solve for the unknowns. This is a quadratic, so I'm going to make a note right here, right? Here's my, I'm solving a quadratic. So to solve a quadratic, I need to set equal to 0. And then I'm allowed to choose between a few methods. I can try factoring by grouping, or I can try the quadratic formula. And so what I chose was factoring by grouping. It did factor. Since it factored, I factored by grouping, taking out the GCFs, and so on and so forth. And then right here, I applied the zero product property, right? Set each one equal to 0. And then I solved each one. Now, the last step it says that we need to do is we need to check for extraneous solutions. So I'm going to take my original equation, which was x equals x plus 1 to the 1/2 plus 5. And I am going to rewrite this using a radical because most of the time students are more comfortable with radicals. And I'm going to do my check. First, I'm going to check my solution of x equals 8 into my equation. So I'm going to plug in 8 equals, and I'm checking here, the square root of 8 plus 1 and then plus 5. 8 equals the square root of 9 plus 5. 8 equals 3 plus 5. Check. This one is a valid solution. I'm also going to check x equals 3. That was my other solution. So this time I have 3 equals the square root of 3 plus 1 plus 5. And I'm checking this. 3 equals the square root of 4 plus 5. So 3 equals 2 plus 5. That is not true. This value is what's called an extraneous solution. And so while it appeared we might have two solutions, x equals 8 and x equals 3, we actually only have one solution that makes the equation true. And so we would say x equals 3 is an extraneous solution. Therefore, our only valid solution, or our only solution, is x equals 8. And so they actually do the same thing here. Only x equals 8 is a solution. X equals 3 is an extraneous solution. And they said it's an extraneous solution because they're not equal. Okay, let's move along to the back side. So now we are on page 107. The try these. At this point, you should pause the video and you should try each of these problems.